In this video, I want to take our version of the micro RPG that we created last time, which used polymorphism, and I want to actually build out the RPG mechanic. So what we had at the end of last video was a version that just sort of displayed the enemies and had them do a generic attack of some kind. What I want to transform that into is something that looks more like this, where we're going to have some polish and a title screen, some story information about you shrinking, that you have this quest through your yard to battle with these massive insects to get back to your lab to unshrink yourself. And then you head into combat where you face these insects one at a time. And we've got health bars and the ability for the player to do a couple different types of moves against these foes. And then if the player makes it through all of them, you win the game. And if at any point you die, your health bar goes to 0, you lose the game. So that's what I want to build. This is going to not involve new big picture concepts, but is going to be us taking a lot of concepts that we already know and putting them all together into this project to implement this. And because there's a lot here, this video may go a little bit faster than previous videos as we were building this. So just keep in mind that you can always adjust the playback speed, you can pause, you can go back if something's moving too quickly. So first thing we need to do here is actually create a player class. We've got these insects that have health and other features, but we don't have a player anywhere in here. And the way we implemented this for the ant and bee was via this enemy class that had name, health, art, color, random generator, and the ability to display itself and fight. But we don't have anything for the player. And actually, if we think about it, the player is going to need a name, health, art, color, random generator. So what we can do is just rename this class. It's no longer an enemy class. It's our character class for any character in our RPG world. Let's see if I still have my whiteboard open here. So essentially, we're just going to rename enemy to be character. And then we're going to have another class inheriting from it, which is the player. Visual Studio makes it really easy to rename things. So if I want to rename this enemy class, I just am going to hit Control R and then hit R again. Or you can go Edit, Refactor, Rename if you don't remember the hotkey. And here I will name this character, hit Apply, and you can see that this renamed it here and here in the file. It also renamed my file, and it made sure that B now inherits from character and not enemy. So now we can create our player class that inherits from character. And we need a constructor here. And this constructor is going to need to call the character constructor, which is going to need the name, the health, the color, the text art. So when we create a player, let's say that we need to know the name, we need to know the player's health, and we need to know what color to use for representing the player in the game. And we can pass along the name, health, and color like we did with our ant and bee. And let's just put a blank string here for the text art for a second here. So we've got our player. We could instantiate this inside of our game and ask it to display itself. But now let's go add some art here. So I want to create a new public static string player inside of our art assets, where I'm going to paste in some player art. And I have added, to this I'll make sure that this is linked. I just made some quick ASCII art that we can use for this. So the first one is the player holding like a stick or a sword, and I tried to make it really small so it would look like it's a micro player compared to all of these creatures. And then we've also got some art here for the story intro where the player's surrounded by a bunch of massive blades of grass. So let's just grab this and bring it into our art assets, paste into a verbatim string here, which means that if we go back to our player class, instead of an empty string, we can use our art assets.player. So let's try creating the player. I'm going to create a private player field called current player. And in our run method here, let's create the current player. And I'm going to choose green so that we've got something that's distinct from our yellow, magenta, red colors for our insects. So I am hard coding this. I am just typing in my name as the player's name. What we'll want to do before we wrap this up is actually read in the input from the user. So like display our title screen, ask what your name is, and then construct the player based on whatever is typed in for the name. And that is why I'm doing this construction of the player here and not doing it up here in our game constructor, because we need this to happen after our title screen kind of loads and asks the user a question. So if everything is working, I should be able to ask my player to display itself. And we should see our player up here, tiny little player, compared to our massive ant and bee ASCII art. So we've refactored things, so we no longer have an enemy class. Instead, we have a just RPG character class that is about representing the basic stats of any RPG character in our world. The player is one of those, the ant is one of those, and the bee is one of those. The next step is that we need to have some way for these characters to encounter one another. So I want the player to be able to fight one of the enemies. So if I grabbed like the first thing from the array, I want to be able to say like, hey player, it's your turn to take an attack on the enemy. And I want to be able to say the reverse. I want to be able to say like enemies 0 can in return fight the current player. So it'll be like rounds of combat where the player goes first and then the enemy gets to go after that. And we'll keep going until one of them is eliminated from the combat. Can't do this right now because our fight method that we created in the previous video does not take any parameters. We just made it kind of a generic thing that printed something out so that we could see our fight logic, our polymorphism in action. But now we want to go revisit this and actually say, when we're fighting, we want to take in an opponent. So we're fighting a specific character in the game. As soon as we do this, though, our bee and our ant are going to have errors because we need to override using the same signature. So we can't fight here with nothing. We actually have to say the same thing, that this takes an other character. And let me, I'm going to collapse some of this down here so that we can just see this on just the fight method in our bee. And same thing in our ant. We're going to have to fix the error, collapse some of this down. And let's do the same thing. I'm going to do some copy and pasting here to bring this signature over to my player. Well, I guess since we wrote that, I'll make sure that this is still on the screen. for reference. So we have, whoops, lost a curly bracket here. So all of our characters can now fight another character. So like in my player here, I could, let's use the foreground color using static system.console. The foreground color is equal to our color. We will reset the color at the end, and we will print out something like bright line. Player will put their name in here. Attacks. And I want to eventually be able to like say who they're attacking. But right now I can't do that. If I try to read things from other character, we can display info, we can fight, we can convert it to string, get the type, these things that are coming from object, but we have no way to access the other character's name. So we're gonna have to fix that in a second. But let's just make sure that our kind of generic player fight is working. And we're actually gonna just blow all of this away. We don't need our for each loop from last time. I should be able, as the current player, to fight the first thing from our lists array. So we got our display info, Mike attacks, ... but it doesn't say who Mike is attacking. So if we look back at our enemy, or I'm probably going to do that a couple of times since we renamed this class. If we look back at our character class, name, health, text art, color, random generator, all of those are protected, meaning that only the character class and derived classes have access to it. Here, when we try to reach into another character and say read its name, we're going to get an error. Well, let's do this right line. That we can't access the protected character.name from this character variable. So what we want to do is actually make name accessible, and probably health, and probably color and text art. But we don't want other people to be able to reach in and change the name health. The reason why we made all of these in our character protected was so that we couldn't just accidentally set the health to 0 outside of the character class. Or we couldn't accidentally override the name. Like we couldn't do that here. We couldn't say current player dot name equals a bunch of gibberish by accident. That's going to be disallowed because it's protected. So we still want to maintain that protection, but we do want to allow other people to read those pieces of data. So enter properties. Remember, we are able with properties to control the access in a more fine-tuned way. So instead of saying that this is a protected field, I'm going to make it a public property. So this property is now public. Anyone can get it. Anyone can set it. And then I can say that the set operation is actually protected. So now anyone can read the name, but only the character is allowed to set the name, or a derived class is allowed to set the name. And then I can repeat this pattern here for the rest. So I'm going to make all of these public, and then I am going to remove the semicolon and put in our property get and protected set. So this change has still preserved in my game the ability to prevent anyone from just willy-nilly going in and overriding the name. This will tell us that name is inaccessible, the set accessor is inaccessible. So good, we still have that privacy, that protection. But in our other classes, we're able to actually print out the name if we needed to. No error here. And we could print out the text art if we wanted to, or reach in and grab the color and print it out, which enables us in our player fight method here to say that the player attacks other character dot name. So our player is attacking Fire Auntie here. And if I go back to my game, I can actually make the player do 1 round of combat against our 2 ants and our 1 bee. And remember, the way that I know that is just because we put them in this order: the ant, the bee. So attacking Fire Auntie, Hades, Buzzbee. Let's do a similar change to our ant and our bee. So ant name is fighting other character dot name. And we will come back and revisit this random generation. For now, I just wanted to comment all of this out. And do a similar thing in our bee. The bee name is fighting other character dot name. And go ahead and comment out this. And this makes it so that our player can fight any enemy. Our enemies could fight the player. And actually, our enemies, if we decided we wanted to, could fight one another. So we should see the player fighting each of the enemies in turn. Then our first enemy, the Fire Auntie, should fight the current player. And then Fire Auntie should fight Hades. So a player attacking each one of them in turn, the first ant hitting us back as the player, and then the first ant hitting the second ant. So we've just refactored things so that basically any character can enter battle with any other character. And let's throw that here. Any character can battle any other character. And to connect the thread to our previous video, what's powering this is polymorphism. We didn't have to create a fight method in the player for bees and for ants. We are just going to treat whatever it's fighting as a character. So we'll be able to access the health because that lives inside of the character class. We'll be able to access the color, the name, and if we add anything else to the character class, we'll be able to access those too. Okay, so we're making progress. We still got a bunch of features to build, so sometimes it's helpful to map out what we want to do in pseudocode. So in terms of the battle logic, like this is great for testing, but what we actually want to happen is to show the health and hopefully show like some health bars. So we could say show health bars. And this will be the first thing we do so that the player, when it's the player's turn, can make an informed decision about, what attack they want to use. After we display those health bars, then we want to do this like current player.fight. So we want to let the player attack the current enemy and display the results. After the player does their attack, we want to re-show the health bars. This is so that we can actually display like the difference. If the player, based on the health bars here, decided to take a swing at the enemy and it was successful, we'd want to show the updated health bars. So re-show the health bars so player can see the result. What we'll need to do after that is check if player or enemy is dead. So depending on what has happened here, we might be done with combat. The player might have taken a hefty swing at the enemy, knocked the enemy out, and we're done. So we do need to check that as soon as the player has finished their move. We'll exit our loop. We'll kind of like leave combat when that happens. But if no one is dead, then we can let the enemy attack the player and print out the result. And all of this is going to be in a loop, because the combat is going to take multiple rounds where we're going to show the health bar and let the player make a move, let the enemy make a move, and then repeat. As long as no one has died, as long as the combat is still running, we want to keep doing this until either the player or the enemy is defeated. So that's our roadmap. We got a few things to do to build that. We got to build some health bars. We need to create some way for the player and the enemies to damage one another. Because remember, we made the health here protected. So we're going to need to provide another way to modify the health. So we'll need to be able to display health bars, take damage, and then we'll need to actually build out the logic. So when it's the player's turn, we want to give them a couple of options of what they can do. And same thing when it's the enemy's turn, we're going to have to build in a little bit of that random AI logic to give the enemy some interesting but simple things to do. So I think let's start with figuring out how to take damage. So what we want to be able to do is, with the player or with an enemy, be able to say something like take damage and pass in how much damage they should take. And then the character class can take care of updating the health based on this damage. So let's comment that out. We don't want to write that logic in our player because the player is not the only thing that's going to need to take damage, and we don't want to like copy and paste it and implement it in B and Ant as well. So this is a situation where it would be good to put it into character. So I can create a public method down here. We're going to use void because taking damage doesn't need us to return any information. And we want to know how much damage to take. And then the character class here can take care of updating the health. Remember that health is protected, so character class has access to actually set the health. So we can just subtract the damage amount. And then to make our life easier in the future, when we're trying to display a health bar, let's make sure that the health can never dip below 0. So if the health is less than 0, we will force the health to be 0. So this should take away health and cap it at 0 for the minimum. So if we flip back to our game, let's display the, well, I guess we could use display info, which displays the health, but let's just print out the health here. Starting health. Current player dot health and ending health. So we should see our health start at 50 and after we take damage drop to 40. Starting health 50, ending health 40. And if we took 5 more damage, we should drop to 35. Starting health 50, ending health 35. So it looks like it's working. And because that logic is inherited to our enemies, we should be able to take enemies 0 and have them take damage, in addition to have the player take damage. So our player took some damage, and then our first ant took some damage here. And to make our lives easier, rather than having to use an index to pull an enemy each time, let's create a field called current enemy. And it's of type character, because this could either be an ant or it could be a bee. And we can say that the current enemy is enemies 0 here, and then I can just use current enemy. So what our loop will eventually do is load up a current enemy, fight that enemy, and when this is done, go grab the next current enemy. And we'll always be able to refer to who's the combatant, who's the opponent, using this current enemy field. So this should still work. Let's run it, make sure. Good. So we've got the ability to take damage, which means that when we do this fighting combat, our player could talk to the other character and say, you know, I just did an attack for 5 damage, so you go take some damage. And same thing can happen in our ant. Our ant class can deal out some damage to the other character that it's fighting. So we've made something that will allow us to implement this combat. But before we get into this logic here, I am tired of just reading the numbers as printouts here. What I would like to see is a health bar that maybe, like when we print out the player's health, it should say like Mike's health, and then something like this. A little ASCII art health bar. And because we can use color, we could actually, instead of displaying a bunch of equal signs here to indicate that the player has half health and has half their health missing, we could just display some background color of like green here, and then we can use this background color of black, and we'll get something that looks like a health bar, where it starts with the opening square bracket, closes with the square bracket, and is filled in based on the player's current health. So it'll start out with a bunch of equal signs or with a green bar filled, and then as they lose health, we'll take away and put some empty spaces here. So like with our take damage, we want to display a health bar for the player and for all of the enemies. So this would be a good thing to implement in our character class, so that we don't have to re-implement it in ant and bee and player. So let's create a display health bar method here, and this is going to not return anything. We're just going to directly paint to the console window, and we're going to do something like print out name. Whoops, make this an interpolation string, names, health. And then we will print out something like this. This is not how we're going to do it in our code, because we actually need the health, the current value of our health, to drive this. We're going to use that number to figure out how many spots to fill in the health bar. We do need to add one thing before we can finish implementing this. So right now, when we create a health bar, we need to know how big it is. Like, what is the character's maximum health, so that we can know, oh, they only have 10 hit points out of 20. We will draw 10 filled spots and then 10 blank spots, so that we get the total bar being 20, or representing 20 hit points. So this is pretty easy. We can just come back up here and let's create a new public int max health field. And same deal, we will make it publicly readable, but protected in terms of who has access to set it. And then we can just build our game to assume that the health that we construct a character with is their maximum health. We start them at max hit points. if our game doesn't meet that logic, like if sometimes you create something without max health, we'd have to come back and update this. But this feels like a fairly safe assumption to make for our mini RPG here. We're always going to start things off at their max health. So what we need to do here is break this bar apart. What we need to do is print out this on the start of a line. At the end, I guess we can use right line here since it's the end of the line. Print out the closing end of our bar. And then in between, we need to draw health, hit points that are filled in. And then we need to draw the rest as not filled in. And there are a number of ways that we can do this just so that we don't have to invoke new concepts. We could just do a for loop. So we loop over how many hit points there are and draw a filled in spot for each of those. So let's set the background color here so that we can fill it in, and we'll use green as our filled in color. And for int I is 0, I is less than our health. So for every hit point we have, we just want to print out, whoops, not right line. We want to make sure that this is right, a blank space. So down here in terms of our equal signs, that means that we're going to draw a green blank space for every hit point that we have. And then this part of our bar, we just need to loop from our health to our max health to figure out how many not hit points we have. Or missing hit points we have would be a better way to say that. So we can start this off as black and loop from I is 0 to, or not I is 0, I is our health. And we want to stop when we hit our max health. And still we're going up by 1. And here we can write a space, but this space is going to be filled in with our black console color, and this one's going to be filled in green. So however many hit points we have, they'll show up in green, and then any missing hit points here are going to show up in as a blank space. So all we need to do here, I think I want to add a little bit more color. So let's set the foreground color equal to the character's color for this health's name, and then reset the color afterwards. And then here, let's reset the color after we finish drawing our bar, so that the closing of our health bar here shows in the default color. Let's cross our fingers and give it a shot. Current player dot draw, whoops, display health bar is what we called it. So instead of printing out the starting health, we can just display the health bar, take some damage, display the health bar again. Haha! So we have our player showing up in their color, then a white opening to the health bar. Here's all of their health filled in at the start, closing the health bar, and then we redraw it after they've taken 15 hit points of damage, and that part is missing from our health bar. So we could do the same thing with our enemy. Instead of printing out the enemy health, we can display a health bar and display a health bar after taking 20 damage. And of course, these health bars are massive. So I think we need to adjust how much health each character has before moving forward, but it looks like it's working. Let's try doing something crazy, like taking a ton of damage to make sure that we don't break our health bar. And look, it's completely empty. And the reason why that didn't break our health bar is because we capped the health, so the health can never go negative. So let's adjust the health here. Let's not make this, let's 100, we'll say, let's just do 10, like, or we'll kind of make them more difficult as we go. So the first ant has 5 health. The next one has 10, and then Buzzbee has 15. And let's say that the player needs like 20 hit points. Okay, that's looking better in terms of health bars. I would actually like to glance at this and see the number here, because it's hard for me to tell like what is my actual health using the filled bar and unfilled part of the bar. I could count it by just moving my cursor, but we could just refactor our health bar here at the end to print out when the bar closes the health out of the max health. So we're not actually doing division here. We're just saying like, this is how many hit points you have, slash, here's your max hit points. Much better. So now we can at a glance, we get a nice graphic, but we also get the ability to at a glance tell what the health is at. Okay, I don't know about you, but that feels much better in terms of the user interface. I tend to be a visual person, so getting something in here feels good. Now we can move on. We've got the health bars. We've got the ability to take damage. We can start implementing the fight logic. So it's probably going to be easier to start with the enemy logic. That's a little simpler. We're just going to use random number to determine whether or not the player is able to, or the enemy is able to hit the player. And once we finish that, we can fill out the player's attack logic. Since we are working with an ant as the first thing in our list, let's do this logic in the ant first. And then later, when we polish things up, we'll make sure that we give the bee some fight logic as well. So if I flip back to my ant, here we had the charge and bite methods that were kind of placeholders when we were learning. The charge charged forward, displayed the item that they were holding, the bite chomps viciously. We could incorporate these later, but for now, let's just create the logic here in our fight method. So we're going to bring back our random number. And let's say what we're going to do here is the options for the ant are going to be really simple. 50% of the time, it will hit with a bite, and 50% of the time, it will miss with a bite. And maybe when it hits, we'll say this does 4 damage. So that's what we want to implement here. It's really simple. I'm using AI in quotes, logic. And so what I'm going to do is, instead of calling this random num, let's call this rand percent, because we are thinking in terms of 1 to 100 from this random generator that we used last time. So 50% of the time, if rand percent is less than 50, or actually less than or equal to 50, that's when we're going to hit. We'll do our damage. Otherwise, we will miss and not do any damage. So we can say something like this. Let's use write. Ant name bites at other player dot name. And space. So we're doing this on one line without finishing the line, so that here we can say, we can finish the line and say, and hits for 4 damage. And here we could finish the line and say misses. So either way, it's going to start with saying that, you know, ant Hades bites at Mike, and then if it's successful, hits for 4 damage. If it's unsuccessful, it'll say misses. And let's do our damage here. Other character dot take damage 4. So this should be good. I think we can, because we're just using this for learning, we can move this out of the way and comment it out. And let's grab our reset color. We want to change the color for all of this logic, and then when we're done, we'll reset the color. So let's get our ant attacking our player. So I still want to store my current enemy as the first thing in my list to make sure that we've got an ant in this field. And let's display the current player's health bar. And then let's say that the current enemy fights the current player. And then we can display the health bar again after the combat. So our health shows up, fire ante bites and misses, and then our health is the same. Fire ante does 4 damage, and we can see our health drops by 4 points, and we can see that readout over here. And probably an easier way for us to, because we're dealing with random here, to see this in action is to just like copy and paste the display, fight, display, fight, display, fight, just for testing purposes, so that we can see a couple rounds happening here. Oh my goodness, all of them missed. There we go. Bites and misses, hits, hits, misses, and each time we can see that the health is dropping down. Okay, so we can get rid of some of that test code. Again, big picture context, we are working towards building out the features so that we can put this loop together, which required us to have the displaying of the health, the taking of damage, the enemy fighting the player. The last piece here, before we can work on putting it all together, is the player attacking the enemy. So we can head into our player fight method, and this is going to look a little bit different than our ant because the player, we need some input to decide what the player is going to do. So let's move this out of the way and comment it out. We no longer need to say that the player attacks. We can say something like this, right line. And we'll use a verbatim string. You are facing. Ooh, actually, let's use a verbatim and interpolation string here so that we can use multiple lines and we can insert variables. So you are facing other character.name. What would you like to do? And then I can hit new line and let's add a space and say 1. You can do a weak attack like pick up a clump of dirt and throw it. Or you could try a strong attack, like take a mighty swing with a stick. Remember, we're tiny, so maybe this is actually like take a swing with a twig, a very small twig if we're the size of a quarter. So this should print out our menu to the user, like, hey, here are your options. You can do one of these 2 things. And if we want to let the user know like specifically what the probabilities are, we could say this has a 90% chance to do 2 damage. And this has a, let's say that this is like a riskier thing. So 50% chance to do 4 damage. So we print this menu out, and then we need to get the response. So we could read line like we've done before, or we could read key. So this will be like what we did with our maze. We are reading in the next key that's pressed, and we are making sure that we don't display, we intercept, we don't display what key is pressed to the window. And then if the key info dot key is equal to console key dot digit 1 d1, then we know that they are we'll put a placeholder. Throwing dirt. Else if the key info key is D2, then we are mighty swing. Again, just placeholder. We'll add the actual random damage in here in a second. And then if they pressed any other key, then let's right line, that's not a valid move. Try again. And we are just going to restart using recursion, the fight method, and we'll make sure that we return, which is a good thing for us to do after we kick off recursion so that nothing else inside of this function runs when our recursion wraps up. So this is just going to restart us back at the start here with displaying the menu and letting the user try clicking one of the valid options. So that was a lot. Let's make sure that this works. So we've got our player displaying the health bar, taking the enemy taking a round of combat against the player. Let's change this a little bit. So let's do the current player display health bar, the enemy display health bar. This matches what we want to do eventually with showing both health bars. Then it's the player's turn, so current player dot fight enemy, current enemy, and we can display the health bars again after that round of combat, and then we'll let the player, the enemy, hit the player and display the health bar again. Okay, so we are facing the fire ant. What would we like to do if I press anything other than 1 and 2? I just pressed it a bunch of times by accident. It's going to redisplay the menu to me and say, hey, try again until you actually choose 1 or 2. And when I choose 1, it says throwing dirt. Our health bars redisplay. The enemy takes a turn. Our health bars redisplay. And let's comment out this enemy logic and just focus in on the player's fight logic. And let's try number 2 here. So we're facing the fire ant and we take a mighty swing. So that looks like it's working. Our conditional is working. The else with the recursion to keep prompting us is working. So we can head back to our player here. And for both of these, we kind of want to do something similar to our ant, that the throwing dirt is a high probability of success, low damage, but it's going to look like this formula where we're going to get a random number. We are going to check if it is less than or equal to 90, since it's a high chance. If they are successful, it'll do 2 damage. Otherwise, it'll miss. That would be a lot of logic to add here and would make it hard to read the fight method. So what I'm going to do is create a private throw dirt at method that takes in a character. And we will say that this is the other character. And let's do the same thing, private swing, whoops, at character, other character. And forgot the void up here. So both of these are just going to be our methods that actually do the random probability of making sure that 90% of the time it's 2 damage and the rest of the time it misses. So instead of saying throw dirt, here we can say throw dirt at and pass along the other character that we have received here at the start of fight. And do the same thing here, but with swing at. And we're making this public, so this is our entry point for fighting. The rest of the world is, like our game class, is able to initiate fight. But these are internal. These are the player's moves that we don't want anyone to be able to reach in and just like force the player to throw dirt at. This is going to look like our ant, where we are going to generate a random percentage. So right line, or actually right. What are we doing here? We're throwing clump of dirt, so we can say you throw a clump of dirt, space, and if it was successful, we'll finish that with right line, and it hits. Else, right line, and it misses. And we just need to fill in the condition here using our random generator. And because player is a character, we have the handy random generator here that is accessible to us inside of player. So we could say random percent equals rand generator 1 to 101. If the rand percent is less than or equal to 90, we're hitting, whoops, random generator dot next. And here we can then do our damage, which I believe we said this is 90% chance to do 2 damage, 90% chance to do 2 damage. And let's go ahead and bring this over here. And instead of throwing a clump of dirt, you take a mighty swing. And we said that this was a 50% chance to do 4 damage. So less than 50. We can say, and it connects solidly. Take 4 damage, otherwise it misses. So taking a quick glance to make sure that this looks right, and we are appropriately calling those methods here. Good, okay, so let's give this a shot. We should now be able to fight the enemy here and choose either of those attacks. Whoops. Somehow I alt-tabbed out of my console. Here we go. So let's try the 90% chance. Throw a clump of dirt and it misses. Great. You know what? To make this testing easier, let's wrap this in a loop. So this will get us closer to what we're going to do here. So we're going to display the health. We are going to let the player make a move, wait for a key, display the health, player move, wait for a key. And this is an infinite loop. So technically this would run forever, but that's okay for our testing purposes. And it's not going to crash our software because we are pausing here at the end and waiting for input. So even though it's an infinite loop, it's not as dangerous as some of the infinite loops we've written before. So this will just let me do a couple rounds of combat to make sure my random generator is working. So let's try throwing, clump of dirt, it hits, haha, and their health drops. Let's try mighty swing, connect solidly, their health drops to 0. Let's see if we can get it to miss. Perfect, and it missed. So for testing purposes, it probably would have been good to bump up the fire ant's health to like 100 and then just try a couple rounds of combat to make sure that our hits and misses were working. We just lucked out in that it worked with just 4 rounds of testing. We got a miss and a hit for both of our attacks. So because this is an infinite loop, this is going to keep running forever. So I'm going to have to force quit this by hitting escape. Let's try and put this into a very simple loop where the player attacks, the enemy attacks, the player attacks, the enemy attacks, and that's where we'll wrap up this video. So we've got our infinite loop. We're displaying the health. Let's actually clear the screen. And after we display the health, let's add a extra space before the player attacks. Then we can add some extra space. Wait for a key to be pressed. Then we can clear the screen and re-display our health bar here. So it's basically going to show the health, the starting health. It'll show the result of like, oh, you hit for 4 damage. It's going to wait. Then we will re-display the health bar and do our enemy fighting. So our enemy will be able to fight the player. And then let's wait for a key. So this will wrap around to the start. So this will say something like, oh, the ant hit you for 4 damage. When you press your key, it'll take you back, display the health bar, and then give you your next round of combat and go forth. So we should be able to play 1 round against one of our opponents. Or sorry, you can play multiple rounds against one of our opponents. So throw a clump of dirt, it hits. Now the fire ant takes their turn, hits for 4 damage. So after I hit a key, my health updates, and now it's my turn. Let's try a mighty swing, and we won. But because this is an infinite loop and we do no checking to make sure that both combatants are still standing, this combat continues on. So I can keep trying to attack, and the undead fire ant that has 0 health is going to keep hitting me. So, we did a ton in this video. We've still got a little bit left to do to kind of polish it up, get it to the final state where we actually go through multiple rounds of combat, and we get our intro and outro screen, which will help us learn like a few new concepts along the way, or practice a few concepts along the way. But we got a lot going on here that involved polymorphism and updating our inheritance tree so that we had this base character class that all of our RPG characters inherited from. Didn't matter whether it was an ant, a bee, or a player, they all have the same RPG stats, and they all have this ability to fight another character. In the next video, we'll wrap it all together. We'll get the multiple rounds of combat going in there. We'll get a game over screen, an intro screen, and kind of package it up into one finished micro RPG.